Okay, so on the board, so we're going to, you'll have to actually place those traces yourself, okay? So, if we do this, now we're going to talk about what actually happens in the manufacturing process. So you're going to have, in multi-board, it represents the PCB that you're going to end up getting manufactured. The PCB is a substrate of some sort. And for simplicity, most of us will use FR4, which is a fiberglass PCB. And it's built up of many parts, okay? So when it goes to manufacture, this is what's going to happen. You're going to have, let's take a very simple two-layer board. So you have a top layer and a bottom layer, which is the most common kind of board that you're going to come across. It's going to have a core in the middle. Okay, and this is some kind of pre-preg, some kind of isolation board, which is not conductive in any way. Yeah? And then on top of that, on both sides, you're going to have a copper layer. You're going to have a top copper and a bottom copper. And then, on top of that, you're going to have a solder resist. Sits on top of there. Okay? And then finally, you're going to have what we call the overlay. It goes on the top. Very on there. Very top. So when the manufacturing people are making your board, you've taken your multi-board project, you've put all the traces, you've connected all your components together, you've moved all your components in the right place, you know that there's stuff on the top, there may be some tracks, there may be some other components on the bottom. Yeah? So it's going to go to the manufacturer is going to build this board, this two-layer board. They're going to have this core, and they're going to have two bits of copper on both sides, and then they're going to etch on that copper based on the Gerber files, or Gerber files, however you want to say. They're going to etch using ultraviolet light the pattern of your tracks on those copper surfaces. And then those copper surfaces are going to have a chemical applied to it that's going to etch away or dissolve the copper that doesn't have a track traced on it. Yeah? So it's almost like when you're projecting using ultraviolet, when you're projecting the image of your board onto the copper, you're putting a barrier on there which stops it from being dissolved in the chemical. And so then you'll end up with all your copper traces, bare copper traces that will begin oxidizing straight away. And they pour the solder resist, which is the chemical paint, over the top and the bottom to stop that oxidization happening and to provide a electrical isolation between all your tracks, etc., to increase the spark gap, as it were. And then once that's dry, they will put the overlay on the top and the bottom, which is basically printing your text and your ident numbers and component idents, etc. So if we were to look at that slightly deeper, let's say you had a 4-layer board, we would have the core. Sorry about the quality of these pens. There's one. So we'd have a core here, and then we might have a layer, a copper layer here, a copper layer here. And then we would have another piece of pre-preg material here, another isolator, and then we'd have another copper, and then finally we would have our solder resistance on the top. Notice there's no solder resistance on the inner layers. And then finally the overlay on top of that. So this is a 4-layer board. So we have our core. Right, this will be mid-layer 1, mid-layer 2. Yeah, then there'll be some pre-preg, which is basically an insulator. Then you'd have the top layer, bottom layer. Yeah, then your top solder resist, bottom solder resist, and then top overlay, bottom overlay. And these copper layers would all be etched individually, and when it's all ready, the manufacturer manufacturing lab will get these core and the threads, and they'll push it all together and get a big press and glue it all together, squash it all down. So the overall diameter, overall height of this board and this board, the most common is 1.6 millimeter. Yeah, 1.6 millimeter. You can specify thinner boards, 1 millimeter, the price will go up. 0.6 millimeters, the price will go up even more. So you can, it's up to you, as long as the fab or the manufacturing plant's capabilities can do it, then you can choose it and accept the price increase. Obviously, because you've got 4 layers here, this is going to cost more than the 2-layer board. So you've got to base that price as well. And they all work on size. So if you built a big board that's 100 mil by 100 mil, it's going to cost a hell of a lot more than something that you could have squeezed your components down and got a far better, smaller board out of it. Okay? So when you're using ulti-board, you're mainly concerned with putting the tracks on these layers, these copper layers, and the idents themselves will be on these layers on the top. Yeah, that's really all you're doing, and you will see in your toolbox on the left-hand side of ulti-board what layer you're working on and how you can choose the other layer and change the colour. So when you're using red tracks, for example, you're on the top layer, and when you're using blue tracks, you'll be on the bottom layer. So there will be a point where you have put your component, right, let's say we put a conventional resistor, yeah, a through-hole resistor. So that's going to sit here, a through-hole resistor, and then these 2 wires are going to come all the way through the board. This is why we need to drill those holes, and they will get soldered here and here. Yeah? If we've done a surface mount, then that would sit just up here on the copper layer, yeah, and it would be soldered here and here. So you can already see the smaller amount of real estate of the board that's going on there, and you don't need those 2 holes. You may come across a problem where you've got a board, and you've got some component on here, this is the top view, yeah, and you need to get a track across this, but you don't want to touch it, you can't connect to it, and it needs to come over here somewhere. So, for some reason it's blocked because of all your components are there. How do we do that? Well, we would put some vias down, and then drop to the other layer, and then run the track on the other layer. Okay? And what the via would do is, a via is basically a connector that links the coppers together. Yeah, through the board. The manufacturing people put it in for you. So you can put your track on the top here that connects to here, and then another track on the bottom that connects to here, and then another via might take it up to there, and then you can come out on the top again. Yeah? So we use a via to be able to jump from one layer to another layer. You have different types of via. The standard via is a through via, which goes all the way through. You have a blind via that might start on the top and finish on a mid layer somewhere, so you can't see the other end. And you might have a bend via that starts on a mid layer and finishes on a mid layer. You never see it. But again, it depends on the manufacturer's capability as to whether they can do that or not. And you need to be aware that when you put a via down, of the whole size that you're going to be using for that via, because there's going to be a minimum and a maximum that the manufacturing people can do for that as well. So typically a via might be sort of 0.2, 0.3 millimeter hole size, very small. If it goes down to 0.15 or 0.1, it'll be a laser drill to go through it. Yeah, and that's vias. Any questions on that? Anything else?
Shall we get a cup of tea and then you can show them how to make a PCB on PCB Way or any one of the other manufacturers?
Yeah, do that. Sounds good to me.
Okay, get yourself a cup of tea, be about 15 minutes, and then we'll... Now the next bit is hugely relevant to your assignment because you need to talk me through in your report the process of being able to actually produce the PCB, and Mike's going to take you through that as well. Okay, so we'll see you in 15 minutes.